Here in this video, we are solving two problems that appeared in the NEET examination from semiconductor devices. Let's have a look at the first problem. The given circuit has two ideal diodes connected as shown in the figure below. So what do you mean by a diode is an ideal diode? This is one diode and this is one more diode, right? So a PN junction diode is ideal means resistance in the forward bias is 0, resistance in the reverse bias is infinity. That's one thing that we need to know, right? Now let us see how does the current flow is happening in the circuit. From the positive plate of the battery, current will start, it will go through these 2 ohms. After reaching the junction, it has to go this way as well as this way, it has to split. But if you notice little carefully, this diode is in reverse bias. What is connected is negative plate of the battery connected to the positive plate of the battery. So the first thing that we can understand is diode D1 is in reverse bias. As it is in reverse bias, its resistance is infinity, it's not going to pass the current through it. So what we can understand is entire this part of the circuit becomes a dead element of the circuit. No current passes through that because diode D1 is in reverse bias. So what happens is the entire current I, whatever is started from here, will continue from here. This diode is in forward bias because this is P type connected to positive. It will further go through these 2 ohms. It won't go this way because current started from the positive plate of the battery has to go to the negative plate of the battery and comes back. So if you have to draw an equivalent circuit of that, you can write this 2 ohms, this diode D2, this 2 ohms and this 10 volts. This is an equivalent circuit of this, right? This is in forward bias, resistance in forward bias equal to 0. It has no resistance at all because it's an ideal diode. Current I starts from here, it will go this way and comes back. So it's very obvious that these two resistors are in series. So the resistance total of the circuit is, when the resistors are in series, resistance is R1 plus R2, 4 ohms. Voltage given in the circuit is 10 volts. Current in the circuit I equal to V by R, that is 10 by 4, that is 2.5 ampere. The current is same in both these 2 ohms because these two resistors are in series. You know, in series current is identical whereas potential is distributed. So the current through R1 or current through this R3 is equal to current through R1, current through R3 equal to 2 ohms. Current through R2, this one, equal to 0 because it's not participating in the flow of the current in the circuit. That's the answer for the problem. Let's have a look at the next question that is available for us. A NPN transistor is connected to a common emitter configuration. What do you mean by a common emitter configuration is for both input as well as output, emitter of the transistor is common. Mean to say input is taken between base and emitter, output is taken between collector and emitter, where this emitter is common for both of them. That's called common emitter configuration, in which collector voltage drop across the load resistance is given as 0.8 volts. See, what is given for you is voltage across common collector is given for you 8 volts. Resistance across the collector is given for you 800 ohms. What is given for you further in the problem is voltage drop across the collector, V equal to IR, that is I across the collector, and the resistance across the collector is given for you as 0.8 volts. So V across the collector is given for you as 0.8. I across the collector I have to find out. Resistance across the collector is given for you as 800 ohms. So I across the collector is 0.8 by 800. This is 8 into 10 power minus 1. This is 8 into 10 power plus 2. So minus plus 2 will go to the numerator and becomes a minus 2. Minus 1 and minus 2 is minus 3. So current is 10 power minus 3 ampere, which is also called as 1 milliampere. So answer for the problem is 1 milliampere. Like that we can solve these two simple problems. Thank you for watching.